Welcome back again, y'all, to the second half of this 3.1. So 3.1 part D. So we're looking at conjugates and division of complex numbers. So what's a conjugate? Good question, class. So it is a complex or imaginary value that you multiply to another complex or imaginary value that will make it a real. So for example, and this is a lot simpler term. So let's look at it. So a conjugate of this is the exact same thing, but with a negative sign. So it'd be negative 3. But then we switch this to minus 7i. So what will make it a conjugate is when we switch these signs right here. And we'll see here in a bit why. So the conjugate of this one will be 14 plus 5i. And the conjugate of this, out of habit, is negative 8i. Now, it can also just be a positive ai, and we'll see why, but negative ai just out of habit because we're switching the signs. So let's look at why that matters. Well, when we multiply the conjugates to these numbers, the conjugates to each other, it creates a real number. Let's see that. So we can take 5 plus 7i times 5 minus 7i. 5 minus 7i. So we still distribute just like we did in the last video. So 5 times 5, 25. 5 times a negative 7i gives us a negative 35i. 7i times 5 gives us a positive 35i. And that positive 7i times a negative 7i gives us a negative 49i squared. So combining like terms right there, they cancel each other out. And that's the main thing about what conjugates are doing. We get rid of these i's right here. And well, this I will disappear because it'll square root into a negative 1. So our i's are gone. Our imaginary numbers are gone. So we're left with just 25 over here. That's now gone. And then negative 49 times a negative 1 gives us a positive 49. So we add them together, we get 40, 50, 60, 74. Whole real number of that. Look at that. Look at that. No more imaginaries. Let's look at 8i over here. Now, the reason we kind of out of habit is to continue with a negative 8i is so our answer at the end will be positive. So if we were to do this, we end up getting negative 64i squared. Remember, so we got negative 64 times a negative 1. Well, that gives us a positive 64. Okay. Now, these conjugates are very important to remember because that is what we do when we divide. So when we divide complex numbers, for example, here, just the same rule as before, you can't have radicals in denominators. You cannot have imaginary numbers in denominator. We have to get rid of all that. What happens on top? We don't really care. What's at the bottom is what matters to us. So for example, right here, we want to get rid of this I right here. So we're going to multiply it by its conjugate, negative 5i on the bottom. But what you do to the bottom, you do to the top as well. That's the thing about dividing. You're actually going to be multiplying here, a lot of multiplication. So on the top, 2 times negative 5i, we get a negative 10i. On the bottom now, though, we got negative 25i squared. Well, negative 25 times a negative 1 gives us a positive 25. And the top, we're left with negative 10i. And then we can reduce, of course. Let's go ahead and reduce. So this is what the division side of it comes. Now that all the i's are on the bottom, gone, and whatever's on top doesn't matter, but it's gone, this is now a more, I want to say more better, but it's prettier. Cannot have radicals, and you cannot have imaginary numbers in the denominator. So let's reduce this. They both reduced by 5. We're left with negative 2i in the numerator, and then 5 denominator. There we go. So let's look at this next one. Same concept here. We got a 6i on the bottom, so we're going to multiply it by the conjugate, negative 6i, negative 6i. All right, so let's do that. So on the top, we're going to distribute this negative 6i to both, there and there. So in doing so, we're left with positive 24i plus 36i squared. And on the bottom, we're left with negative 36i squared. We simplify this down here in the bottom. We're left with now a positive 36. Remember this negative 36 times a negative 1. So you got positive 36. On the top, we still got the 24i over here. But this, we got a positive 36 times a negative 1. So we got negative 36. Now, let's think about this. What can we factor out of this that can reduce it down here? Now, everybody wants to automatically just cancel that out. But no, remember, this whole single number down here has to reduce with both of these in the same manner, in the same way. So if we factor out, let's say, a 12. Let's take out a 12. A 12 out of 24, we're left with 2i. And a 12 out of 36, we're left with 3. And then we got 36. This now reduces right there. 12 goes in 36. How many times, y'all? 3 times. And this becomes a 1. So on the top, we're just left with 2i minus 3. And on the bottom, we're left with just 3. This does not reduce. Y'all remember, this is one thing right here. So if we can't go into both, then we are done. That is a reduced complex number right there. Let's look at the next one. Now, we have two complex numbers, one on top. This whole thing's 1. This whole thing on the bottom is 2. The other one. So we have 2. But the only thing that matters to us is the bottom. Remember, so we multiply by the conjugate. The conjugate of the bottom one is a 5 plus 2. I remember we switched that sign. And we do what we do to the bottom, we have to do to the top. All right, so that times that, that times that, that and that. So on the top, we're left with negative 35, which is negative 7 times 5. And negative 7 times 2i gives us a minus 14i. I'm going to switch colors so these don't run into each other. Negative 35 minus 14i. Good. And then negative 10i times 5 is negative 50i. And then negative 10i times 2i gives us a negative 20i squared. And on the bottom, multiply those two, you get 25. And then plus 10i minus 10i, and then minus 4i squared. So let's simplify the top. So that and that. So we got negative 35i. So negative 35i. Then negative 14i minus 50i, we negative 64i. And negative 20i, negative 20 times a negative 1, left with plus 20. So we simplified this here in the bid some more. On the bottom, these cancel each other out. And this negative 4 times a negative 1 becomes a positive 4. And then 25 plus 4 is 29, the denominator. So as far as what needs to be done, we're good. We got rid of the I in the bottom, but let's go ahead and reduce this. So negative 35, negative 35, sorry, plus 20, because this is negative 15. And then minus 64i all over 29. And that's it. That is our final product, y'all. Hopefully this helps you guys out. Catch you on a different day. Bye.